Good morning. I'm going to talk to you today about the second major in systems engineering. I'm Prof. Chia. I'm in charge of this particular second major. Okay, so let me first introduce to you what is the systems engineering, right? As you can see from the slide here, you have all the different hard disciplines like electrical engineering, chemical engineering, civil engineering, and so forth. And each of them will actually develop components or systems within their own discipline, right? But who is going to put everything together? And that's where a systems engineer will come in to do that, right? Let me give you an example, right? Now, if you are going to build an airport, okay? Now, an airport requires a lot of things. Of course, you need to build the infrastructure. You need to have your check-in counters, you need to have your electronic systems for check-in, and so on and so forth, right? And each of these disciplines, for example, civil engineering will take care of the infrastructure, and then electrical engineering will take care of the power supply, and possibly also the computer systems, and so on and so forth, right? But how do all these things come together? And you need your systems engineer to really to make sure that everything are integrated together, everything is nicely, coherently put together as well. So this is one example of what system engineering does. The next slide I want to show you, on the left-hand side, right, you can see that system engineering consists of a lot of other things that we consider, right? So for example, let's talk about hardware and software, right? Now you can see that that previously hardware is dominant in many systems, right? But nowadays with digital engineering, software becomes more and more important. Okay, now then who is going to look at how the software is going to interface with the hardware and vice versa? And that's what the job of the systems engineer does. Okay, and if you look at it, right, at the requirements part of things, the system engineer is responsible to make sure, right, that the customer or your client, right, requirements are all being met, and the system engineer does it by making sure that they are verified and validated as well. And of course, to do that, right, they have to consider all the human factors. They have to make sure that you have to lead the team. That's where your project leadership comes about. They also have to manage risk, right, to make sure that the system is delivered on time, within the budget, and so forth, right? But ultimately, system engineering is about integration, right? Which I mentioned in the earlier that how you can put everything together and how you're going to integrate all your components, subsystems, and systems together. Okay. Now, if you look at the right-hand side, right, it talks about the interfaces of system engineering to other fields. Now, system engineering is not just about integrating engineering disciplines, right? You also have other fields like businesses and so on and so forth. So all these other fields like management and all that, you need to really get the systems engineer to put all these things together. Okay, again, the key word here is systems, right? So again, when you talk about systems, you need to consider a lot of other things apart from particular disciplines in engineering. Next, I want to talk a little bit about complexity, right? Now you can see that the world is becoming more and more complex. Why? Because things are getting more and more connected, okay? Now, when things are connected, then where is the interface, okay? Say, for example, right, when you connect your supply chain to your systems, okay, your supply chain system to your system, then who is going to look at the integration between these two systems, okay? And as more and more systems get connected, it increases the complexity. And that's where, again, the system engineer will have to come in to tackle the complexity itself. Now, this slide shows you the UN sustainability goals. As we all know, right, sustainability is a big thing nowadays, and we have to look after our planet. But sustainability is not just about or environmental sustainability, right? So if you look at all these goals here, right, you can see that each of them by itself looks, that, okay, I can tackle it by itself. But if you start looking at from a systems engineering point of view, you'll notice that they are all interrelated, okay? Now, if you look at number 13, right, it's about climate action, which is something that we are looking at. But climate actions will affect those living things in water, on land, and so on and so forth. Okay. Now, if I do something, say with regards to climate change, but I worsen, the fishes, the animals that live in the water, then I'm going to reduce my sustainability goals or what I can do for those in water or in land, right? So again, the systems engineer will have to come in to make sure, right, that all these things there has to be a trade-off to make sure that you know that exactly what are your goals and how you make trade-offs so that you can actually meet at least majority of the goals set by the UN sustainability. Now let's talk about the current industrial revolution, right? Let's look at the fourth industrial revolution first, okay? If I circle in red, right, you can see that systems integration is a very key component, right, in the fourth industrial revolution. As I mentioned earlier on as well, right, as with the Internet of Things, as things get more and more connected, right, the need for system integration becomes more and more important, okay? So that's why, again, why you should take up the second major in systems engineering, okay? Now, if you look at the bottom part, the diagram, right, you can see that although now we are at the fourth industrial revolution, we are also going towards the fifth industrial revolution, okay? I think there are few things in the fifth industrial revolution, but I just want to talk about the new business models, okay? Now, what do you mean by new business models? New business models means that as businesses evolve, right, they are looking at the new ways of doing things, okay? And very often, these new ways of doing things will actually require things to be integrated, okay? Let me give you an example, right? Now, if you go and buy a house, okay, if I buy a house, right, what do I really need, right? It's not just about buying a house. I need financing, which is now actually included usually as part of the package by the developers. But what else? I also need renovators, for example, right? I also need movers to move my things and so forth, right? So as a developer, if I can, provide this service, a one-stop service to my customer, then my customer will be very happy because now they don't have to go and find out, okay, to search for renovators, to search for movers, etc., etc. Okay, but as a developer, for me to do that, right, I need to have interactions with the renovators, the movers, and so forth. And how do I include all these people, right, in my system? Okay, so that the customer can actually go into my system and select which renovators or movers they think is most suitable for them. Okay, and that is considered one of the new type of business model as well. Right? And again, systems engineering, because of this integration of different businesses and so forth, okay, that will certainly help if you learn the tools and techniques and the concepts in system engineering. Right? So why take system engineering, right? So again, trying to equip you with the fourth and fifth industrial revolutions knowledge and skills. What you will get out of this second major is first, your system perspectives and tools, because as you integrate more and more systems together, right, you must look at things from a system perspective, okay? The second part is about decision making. So one of the things that we look at, how you make decisions using network, information, and data, and how you can optimize your system. What are your biases when you start making decisions, okay? And then finally is your knowledge of new and advanced technological systems as well, because as we start using things like AI systems, machine learning, and so on and so forth, right? And to see how am I going to integrate such new technologies into the system, then system engineering will start looking at all the interfaces that's required for this as well. And you learn about the life cycle. Life cycle is very important because you want to make sure that you capture everything, especially when you start looking at the life cycle costs and so forth. And of course, system engineering provides you with the pie-shaped kind of competencies and interdisciplinary, meaning that you can be in depth for one particular discipline, but you have the broad knowledge of the other disciplines as well. And very often our projects are tied with industry, so you have stronger ties with industry as well. Okay, these are the subjects in major in system engineering. I'm not going to go through that in detail, but as you can see, it focuses on systems engineering, systems kind of topics, as well as those optimization, industrial, human factors, and kind of things in the topics as well. And if you choose to take a minor, which is also possible, those courses are on the left are those that you have to take compulsory courses you have to take as a minor, right? If you want to find out more about the individual courses that I've described to you earlier on, you can scan the QR code or go into the URL, the top one to find out about these courses, as well as the second major in systems engineering. To find out more about other courses and other second majors in CDE, the bottom QR code and URL is for you to access all these different courses and subjects and topics as well. All right. Thank you very much. That's all I have.